So welcome to my talk about rapid prototyping in data science. And the question comes up, what is rapid prototyping? Well, my understanding from a rapid prototype is that you can, data science project which is done in a few days, maybe a week or so. So what can we do with rapid prototyping? Here comes the overview. We have a showcase, first introduction, then a showcase where we use this rapid prototyping, and then a demonstration where you can see partly in real time how we did this rapid prototype, and then I embed the rapid prototype in value creation, I guess an important topic where we should talk about how to create value with these techniques, and finally questions. Now, what's the goal of the talk? The goal is not to have fancy algorithms, but some other things. And here I have to confess something. I changed the showcase from the SNCF, as I announced it as announced. I changed it to a more recent one, and I hope you don't mind. The showcase which I show now is a real showcase which we used to convince SDS AG, a partner of us, to join, to become our partner. And it's rapid prototyping which we did. The first part in one day, where a person of RTS was sitting next to me and looking over my shoulder what I'm doing, and I'd like to show you this and slightly more. And I hope you don't mind that I changed the showcase. And then we come to the demonstration, the main part of this talk, where I'll show a tool from Dataiku which enables such fast prototyping, but it also allows you to change then, once this small fast prototype is successful, to a more big data solutions in terms of changing to Spark within a few clicks. And then in the end we talk about how we can use rapid prototyping to create value for the companies. So that's the goal of the talk. Why do I talk about rapid prototyping and what's my experience? Well, we in the company LinBI provide other companies digital services based on their data, and there we often start with a rapid prototype. That's my experience, and I like to share this to you. Now, why do we promote rapid prototyping? Well, many customers, especially from the industry, often don't know exactly what they should do with data science. And then if you can take their data and the problem from them and then solve it with a rapid prototype, not in a perfect fashion, but then the engineers get the feeling what you can do with data science in a very short time, with a limited budget, and this is often a huge inspiration for the engineers, and because they see what you can do. And then again, it is important to convince the management, and if they see that you can solve in a prototype a problem of them, this is always convincing for the management that you can proceed. And then from the financial point of view, such a rapid prototype is rather cheap to do, and this allows many companies to start now rather to wait until the big budget is coming. So you can start with data science now rather than delay it into the future. And from a technical point of view, it provides a baseline which for the machine learning result, and this often shows you as well what you have to improve in the future. Do you have to change the algorithms, or do you have to invest in the data set, in the feature selection, or collect more data? So these are some reasons why we promote rapid prototyping, and now we come to the showcase which I will show you. So it's the new showcase. It's a dialysis filter production. Dialysis filters are used in case of a kidney failure, also by a Nierenversagen. And here is a picture of such a dialysis filter. For somewhat reason you can buy them on Alibaba, I don't know why, but that's how they look like. And yeah, that's how this dialysis filter look like. And we are analyzing a machine which produces this dialysis filters. And the goal is to improve these machines in order that the product, the dialysis filter, gain in quality. And what we do is we take all the production parameters, some of them are shown here on the left, temperature, thickness, the material properties, and they all have an influence on the filter properties of the produced filters. And now the first goal is to have a machine learning algorithm which takes these parameters and predicts the filter properties, and then we added a sensitivity analysis which is then based on this algorithm allows the engineers to improve their machines. So that's the prototype. As I mentioned, we did the first part of it in half a day while a person of SDS was sitting next to me, and I'll show this, and then in addition this additional part with the application. So now I'll go into this showcase. I prepared this in the program Dataiku, as you can see it here. We have on the left side here to start the original data, then we have data preparation, this yellow points here, until the data is in a form where we can use it for visualization or here for machine learning. And then we use machine learning to predict the filter properties based on the production parameters here in green. And now, the main reason why we use the Dataiku is because data preparation is very fast. And this is really a key point if you want to do rapid prototyping, because otherwise you would lose far too much time. And often this can be done in Dataiku without programming in a graphical way, and I'd like to show you this on this point here, this data preparation point here. So we like to add a new step, and according to SDS, this other company, these D-something values should not be used in the model because they don't like them to be used for some reason. So we're gonna delete those columns. I search for delete columns. I can use regular expression to delete all these columns which start with D, so D point star. And now they are gone. And then there is some other small problem here with the material properties. 2% of them have an empty cell, and we're gonna delete these these rows. So I'll go to analyze. We see a histogram here of the distribution of these material properties. Go to categories, and we can delete rows where no value is present. So we can, a fast way to prepare the data, and now the data is ready for visualization. So I'll go back to the overview and click the data which you want to visualize. Go to the charts, and now we can add different kinds of charts. One is the Scatterplot, which I like to work with. We are interested in the filter value, and we want to put in the x-axis the material parameters, in y the filter values. You can make the bubbles a bit larger, that you see something. And so we see a strong correlation between the filter values and the material properties, and we can add colors to these points. The thickness, let's make thin green and thick red, and then we see some correlation here as well, if it would go away. So, no. We see that the red points have slightly higher filter values compared to the thin ones, the green ones, which have smaller filter values. And this is a way how we can visualize the data in drag and drop fashion, which is very fast, produces nice results, and also important if you want to do a rapid prototype that you have a tool which visualizes the data very fast. So now we saw data preparation, data visualization, and the thing which remains is the machine learning algorithm, and I like to show this here in live how you would do this. We click on the training data, which is the old data, and the test data, which is the new data. So the test data, we create a lab to allow machine learning. We go to the models. We'd like to train a new model. We can choose between clustering or prediction, but we want to predict the filter value based on the production parameters. And so that's what we do. The target is, as we already discussed, the filter value. And now we have the option to choose the underlying library. We will choose the Python library scikit-learn, but you could also use Spark, MLlib, or H2O. And this is an important feature, right? That once you have a small rapid prototype, you can, once this prototype is growing because it's successful, then you have to change to some other libraries, highly parallel, like Spark. You can do this for the machine learning as well as for the data preparation points. So very important that you can let your small rapid prototype grow into a real big data solution. So but now we use scikit-learn. We go to the settings. We have to adjust some settings. We have these two data sets, training and test set. So we choose the training set for the training and the test set for the testing. And then we have, again, these features, these something which we should not use according to this company, SDS. And we select them to reject them later. So we reject all these properties. Just as a remark, this primary key, which is a unique identifier, was automatically detected that you should not use this in the model. So we don't have to do this. And then we come to the algorithms. I like to train a random forest algorithm. I know that 2 is of a minimum number of leaves, samples per leaf. 2 is a good value for the data set, as I trained it already earlier, so I'll change these parameters. And then you can choose all the different algorithms from scikit-learn by just activating them. And rigid regression is now activated, so why not train this as well? And you could, if you'd like, also add a custom Python model if you have special needs. So we train these 2 algorithms, and this was very easy to select them, and I guess that's also an important property if you want to do a fast prototype. You don't need the best possible model, but you need a model which is at least not too bad, right? So now we see that the random forest algorithm has a higher R2 score, so it's the better model than the rigid regression for this data set. And so I like to go into the random forest model, look at the trees in this random forest. Not really a very helpful visualization, but it's very nice. Anyway, the variable importance is now a less nice but more helpful thing, especially for engineers, quite useful, because if you want to tune these different parameters in order to have a good production, then you would see that the material property is the most important property here, and there is no too little use to fine-tune temperature 2. It would be most probably wasted time. So this is already a visualization which is helpful for the engineers to know which parameters they should tune. And this variable importance was computed by scikit-learn with the Gini importance, and basically there you look on how good these different variables divide the one data set into 2 sub-data sets in the tree. And a good division here means if you have an unhomogeneous set and you would cut it into two homogeneous sets, this would be the best. This would give you a very high importance here. Now we have a short look at the Scatterplot. You probably all know this, that's the predicted value and that's the actual value, and the closer we are to this red line, the better the predicted value corresponds to the actual value. And there is one outlier here with quite a large error of 1.25, but otherwise it's quite a good result. And then the last thing I would like to show for this algorithm is the detailed metrics. You probably know many of these metrics. I'd like to highlight only one here, the mean average percentage error, which is also understandable for a broad audience, and which means that in our predicted filter property there is an error, an average error of 6%. And this is quite a good result if you keep in mind that we did data preparation, visualization and machine learning in half a day while the person was sitting next to me and looking over my shoulder. I was explaining what I was doing. And that was the way how we could convince this company RTS to become our partner. And a common way which we often experience, that if you can present something like this to customers with their own data, their own problem, that's very convincing. And now I'd like to show you this application which we did afterwards, so not in this half a day, but afterwards. So I'll go to the dashboard, and this is this sensitivity analysis. I don't know how many of you know sensitivity analysis, but this is very common in the machine industry. And here you can set an operation point. So here are all the production parameters, and you can increase temperature 2, reduce temperature 1, and then all these parameters will remain fixed, and the only thing which will vary is one parameter, and I will choose the material parameters, material properties. And then you can use the machine learning algorithm, and you give it all these values and ask him to predict the produced filters and the filter properties of these produced filters. And then you get this curve with the material property on the x-axis and on the y-axis, the predicted filter property. And now you can do a sensitivity analysis, and for instance here you can change the material properties and the predicted filter will not change. And so this is here you have a very low sensitivity. And it's completely different here, where if you change the material property a little bit, then the predicted filter property will change quite a bit, and this is a bad point to produce a point with a very high sensitivity. And engineers, machine engineers often tend to search for such plateaus where they can produce the filters with a high constant quality, with a fixed filter property if the material property is changing, and the material property will change in reality, right? There is no way you can avoid this. So if you produce here, then you have a high quality production with constant filters. And this tool will allow you then, using machine learning algorithms, to optimize the production, to find parameters where the plateau is on the right filter property, such that you can do this high quality production. So that was my demo. We saw data preparation, data visualization, machine learning, and then finally an application of it, which is used by the engineers to tune the machines such that they perform optimally. Now I go back to the slides. So we saw this demo of rapid prototyping, but often there is a little bit more required if you want to do value creation with data science. And I think we should also, although this is a technical conference, we should talk a little bit about value creation, and that's what I'm going to do in the last two slides. And if you want to create value with data science, so one way of doing it is you could start with the data which is available and hopefully also relevant, and then you could ask yourselves, well, now we have this data, what should we do with it? Something useful, hopefully, that we can create some value for companies. But the better way, the better approach would be to start with an existing problem, with an existing pain, or with a vision where the company could be in the near future, and then look for the right data. And then with this data, you could do machine learning always with the vision to solve the problem, to lower the pain points, and then you can create value which is really relevant for the company. But this is often hard to do, right? And then this is also an iterative process, and of course we propose to use in the first iteration rapid prototypes, such that you can do the first iteration at least very fast and then decide what you want to do in the next iteration, in the next step. But yeah, that's a hard point, right? To start with the pain. So how should you do this? And we propose often a series of 3 workshops, where in the first workshop we start together with the customer to identify pain points of this company, where is the problem of this company, or possible visions, where could the company go. Then in the second workshop we set the priorities for these pain points, for these visions, and draft possible business cases. And then in the third workshop we refine those business cases such that you can decide on which cases are valuable enough that you can invest a little bit more time and money to build a rapid prototype. And so after 3 workshops of each half a day, so a total of 1.5 days of workshop, we gonna build a rapid prototype for 1, maybe 2 of the relevant and identified pain points, and this is then the basis for the management to decide how to continue. And of course this corresponds to the first loop of the previous slide, like right, we start with the pain points, with the vision, we go over a rapid prototype, and then we can decide on how to continue. So that's the end of my talk. I showed a rapid prototyping demo. In my opinion, it's very important that the data preparation is really rapid and fast, because otherwise you will lose so much time and you could not call it a rapid prototype anymore, because you won't be rapid anymore. And then visualization is always very helpful in my experience, and often this is one point which already creates quite a bit of value if you can provide the right visualizations to the engineers which are working with these machines. They discover new correlations, new points of the data, and also in their machines relatively. And then I hope I could convince you that you can indeed do for certain cases rapid prototyping with machine learning, with data science. And then more from the business point of view, I hope I could convince you that rapid prototyping can be the first step towards a real big data application. And then I finally want to emphasize that we really should care about data science projects which create value, and we should also assist companies to find such value creating cases. And one way is, or one attempt is, to use rapid prototyping, as then this allows companies to try different data science projects in a very short time. So thank you very much.